Hello friends, myself Dr. Amit Bagde, Assistant Professor in Sharad Institute of Technology, College of Engineering, Yadrao, Ichalkaranji. Today we are going to discuss the very important point of our engineering physics syllabus, that is lasers and its applications. So this is the content of today's lecture. First content is introduction to laser. Second is the principle of laser. Third is the kinds of laser. Fourth one is the construction and working of ruby laser and helium neon laser. Then applications of lasers, advantages, disadvantages of laser, and finally conclusions. Introduction of laser. Uh, the word laser is an acronym that stands for light amplification by stimulated emission of radiation. That is, the term laser stands for light amplification by stimulated emission of radiation. Laser is a light source which is highly coherent, that is, the radiation emitted by all emitters, atoms, or molecules in source agree in phase. Direction, emission, polarization, and the essentially of one wavelength or color, that is the monochromatic. So, due to the coherence, a beam of laser light can travel many miles with only a negligible divergence. So, this makes it different from of conventional light sources, which emits many wavelengths with phase and direction widely varying. So, lasers are essentially highly directional, highly intense, highly monochromatic, and highly coherent optical sources. The stimulated emission was postulated by Einstein as early as in 1917. In around 1917, the Einstein first predicted the existence of two different kind of processes by which an atom can emit radiation by spontaneous emission and stimulated emission process. In a laser, the process of stimulated emission is used for amplifying the light waves. The fact that the stimulated emission process could be used in the construction of coherent optical sources was first put forward by Towns and Shallow. The energy of an atom of any atomic system can charge by the three main processes. Okay, that is the absorption, stimulated emission, and spontaneous emission. So in 1960, a solid state ruby laser is developed by Meinman on this principle. So this ruby laser is the first laser which is invented by Meinman in 1960. After that, that is 1961, gas state HNA laser is developed by Ali Jawan and others in Bell Telephonic Laboratory. Next point is principle of laser. So the principle of laser involves the three main processes, that is absorption, spontaneous emission, and stimulated emission. Now let us discuss the first point, that is absorption. What is meant by absorption? Consider the two energy levels. Suppose ground state level and excited state level. Suppose E1 is the ground state level and E1 is the ground state level and E2 is the excited state level. Suppose atoms present in a ground state level and the external photon having energy E is equal to h nu is allowed to incident onto this ground state atom. Then this ground state atoms absorbs this energy and uh, goes to excited state. Goes to excited state. So this process is known as absorption. Second one is the spontaneous emission. So the spontaneous emission is the natural process because there is a natural tendency of this excited state atom, tendency of this excited state atom to have a lower energy configuration. Therefore, atom cannot stay for longer time in excited state. This atom immediately comes to the ground state. So during this transition, this atom emits the radiation in terms of photon energy, but this is the incoherent radiation. So this process is known as the spontaneous emission. And last one is the stimulated emission process. So emission process is very important. Consider two energy levels again same, and that is energy level 1 and energy 2. One is the ground state and 2 is the excited state. Suppose atom present in the excited state. suppose atom present in excited state, and again the external photon having energy is equal to h nu is allowed to incident onto this excited state atom. This excited state atom is absorbs this energy and goes to the uh, ground state. So during this transition, this excited state atom emits the radiation in terms of photon energy. So this single atom emits the two identical photons. So where the electrons are initially the excited energy levels, okay, or the atoms are initially in excited level and emission is stimulated. Before the spontaneous emission occurs, the excited atom is stimulated by photon of exactly the same energy as the photon to be emitted. In such case, two photons are emitted, one by the stimulated emission and other is the stimulating photon. Okay, so this stimulated emission process is stimulated emission is also known as the forced radiations. Okay, so both the photons travel in the same direction, having the same frequency and are in phase, that is they are coherent. The emission of these two photons with an input of only one photon implies amplification. The occurrence of spontaneous emission is directly proportional to the number of atoms in the specified energy levels, whereas in stimulated emission the rate of occurrence is proportional not only to the number of atoms in a excited state, but also to the number of incident stimulating photons. So these are the three main processes which is involved in a laser, that is absorption, stimulated emission and spontaneous emission. The process of exciting the atoms to higher energy level by absorbing the stimulating incident photon is known as stimulated absorption, as we discussed earlier, E1 and E2. This is the spontaneous emission process. The excited atom, after getting stimulated by incident photon, transits to lower energy level by emitting photons is known as stimulated emission of radiation. Okay, so these are the kind of lasers. So depending on the nature of the active material, there are different type of lasers, that is solid state laser, gas laser, liquid laser, dye laser, semiconductor laser. The example of solid state laser, ruby laser, the example of gas laser is CO2 laser and HNE laser. Uh, the example of liquid laser is the European chalate. The example of dye laser is a curriculum dye laser, and example of semiconductor laser is a INP laser. Now let us discuss the two main lasers, that is discuss the construction and working of ruby laser and HN laser. So this is the construction and working of ruby laser. uh, Ruby laser is a solid state laser that uses a synthetic ruby crystal. Typically or typical ruby laser is a pulse laser of intense red color. Okay, now let us discuss the construction of this ruby laser. The laser consists of a ruby rod surrounded by a flash tube. One end of the tube or rod is highly silvered, while the other end is semi-silvered. The flash tube surrounds the ruby rod in the form of spiral. Okay. Synthetic ruby consists of a crystal of a aluminum oxide, that is Al2O3, in which few of the alum atom, that is Al3 plus, are replaced by chromium ions, that is Cr3 plus. So these atoms have the property of absorbing the green light. The chromium impurity is active atom of this laser. So the doping of chromium gives ruby its characteristic red color. Okay, so this is the construction which consists of a power supply, switch, polished diagonal reflecting crystal, 95% reflective mirror, laser beam, quartz flash tube, ruby crystal, 100% reflective mirror. Okay, so the resonator cavity is formed by making one face of the crystal is partial silver and other is fully silvered. Okay, this is construction in ruby laser. Cylindrical ruby rod made up of aluminum oxide, which is doped with 0.05% weight of chromium oxide. One end of the ruby rod is fully silvered and the other one is partial silver, so it acts as a optical resonator or resonator cavity. and the rod is surrounded by glass tube, which in turns is surrounded by helical flash lamp filled with xenon gas. So this is a very important. This is the working of ruby laser. So this figure shows the energy level diagram of uh, ruby laser, that is energy level diagram of Cr3 plus ions. Okay. When the flash lamp light will be flashed on ruby rod, the chromium ions excited to the higher energy state. After staying for up to 10 raised to minus 8 seconds, the ion get transmitted to the metastable state. The laser radiation of a wavelength of 694.3 nanometer and laser emission is pulsed one. Okay. Suppose this is a 3-level laser system. Okay, suppose this is a ground state. This is the ground state. This is the excited states, and this is the metastable state. When flash lamp is flashed, then the Cr3 plus ions is absorbed the light energy and goes to the excited state, that is excited state number 2 and 3. And after that, after non-ready to transitions to the metastable state, all these Cr3 plus ions are comes to the metastable state. So the population inversion is occurred in this metastable state, and uh, after that the Cr3 plus ions comes into the ground state. So during this transition, that is metastable state to ground state, this Cr3 plus ions emits the radiation having the wavelength 694.3 nanometer. If the Cr3 plus ions, if the Cr3 plus ions absorbs the wavelength 5